knock out these examples. If you look in your notes, this is one of the examples. X squared minus 4x. And what we want to do is we want to find the slope of the curve at the given point. And the given point, well, is the given point at x equals 1. All right. So this is just the x coordinates. And we could, right away, we could go ahead and find the y-coordinate. You don't necessarily have to, but if we find the y-coordinate, because you're going to have to sooner or later, but if you find the y-coordinate, it's going to be -3. And again, just plug x in here, so 1 squared minus 4 times 1 equals -3. Okay? So it says, find the slope of the curve at the given point. Now, if we look at the graph real quick, this is what it looks like. This little blue line right here, this is what our graph looks like, and we want to find the slope at this point. See where my arrow's at? If you want to, go ahead and sketch it on your paper. I don't know if there's much room, I forget, but go ahead and sketch it on your paper there and put a dot. There's sketch, and it's about somewhere in here, okay? We want to find the slope of the line through that point, and if we draw our tangent line, this is kind of what over here, this is what tangent line looks like. If we draw our tangent line, it's a straight line. It's linear, not like this, but it's a straight line through that. Our job is to find the slope of that line. Okay? Now, we need to figure out what the slope of the secant line. So remember, in this case, basically what we're doing, it's f of x plus h minus f of x all over x minus h. And so it's going to be basically the slope of the secant line minus the slope of the tangent line all over. Then you would remember you'd have your x plus h, because remember this is the f of x plus h, and this is the f of x part. Okay. So for the f of x plus h, that's the slope of the secant line. You're going to be using this function up here, so you're going to be plugging x plus h in for x. Alright, so we'll put brackets. So this is the part that I'm doing here. Alright, so in for x, you're putting x plus h, and x is 1. Alright, so I'm plugging in here, I'm plugging in the number 1. I'm going to plug in the number 1 for x here, and the number 1 for x here. Okay? Well, it's going to be, sorry, it's x plus h. So it's going to be 1 plus h, and then 1 plus h here. Alright, you catch my drift? It's going to be 1 plus h quantity squared minus 4 times 1 plus h. And that will give you the slope of the secant line. I just want to point out how this is similar to that, and this is similar to that. The only difference is instead of x, I put 1 plus h, and the 1 is your x plus h at x equals 1. Capiche? Okay, if you need to stop the video and go back, that's fine. Then minus, I'll put this in brackets, the f of the x part. So now all we're doing is plugging x in there, and it's already done for us. So it's just x squared, whoops. But instead of x, I'm going to use 1 because we know what x is. It's not erasing for me. There it is. Okay. So it's going to be 1 squared minus 4 times 1. And then remember the x minus x, all you're left with is just h. I forgot to put it's the limit as x approaches h. Okay? That is the hardest step. From here, it's just simplifying, and it'll work out all nice and pretty, I promise. Because when you simplify this, it's a limit as, sorry, not x approaches h, that's something different. I'm jumping way ahead. It's h approaches 0. The limit as h approaches 0, then when you simplify this, 1 plus h quantity squared, you get 1 plus 2h plus h squared. Minus, then you would distribute this negative 4 in, so it'd be minus 4 minus 4h. Then now we're going to simplify this here, the 1 squared minus 4, and that just simplifies to negative 3 all over h still. Okay, now we're still simplifying. It's the limit as h approaches 0. When we simplify this first part, you would have 1 minus 4. So this will be plus 3. And you notice the 1, so let me do this. The 1, the negative 4, and the positive 3 all cancel each other out. Okay? That should happen every time. All your constants should cancel out so that everything that's left, it has a term with an h in it. So when you simplify this, you'd have h squared minus 2h because you'd have plus 2h here, minus 2h or 4h there, so h squared minus 2h all over h, and voila. This is why all the constants should disappear, because every single term has an h. So then it becomes a limit as h approaches 0 of just h minus 2 over 1. Now, okay, since back here, if we plug 0 in, you'd have something over 0, which is undefined. Now we can go ahead and plug 0 in for h. So you'd have 0 minus 2 over 1, which is negative 2. And so that means your slope is negative 2 at that point, x equals 1. Okay, so if we come back here, the slope of this red line is going to be negative 2. That's the slope of the curve at that given point. That's it. Okay? Alright, so now find the equation of the tangent. And all you need for the equation is the point and the slope. And we have the point. And we have the slope. The slope is negative 2. The point is 1, negative 3. Okay? So we're going to put it in point slope form. So it's going to be y minus negative 3, so that becomes plus 3, is equal to your slope times x minus 1. And that's good enough, because on the AP exam, if it's not multiple choice, obviously if it's multiple choice, you may have to put it in a different form, whether it's standard or slope-intercept, whatever. But if it's not multiple choice, if it's one of my tests, just leave it like that. Okay? But for practice, you can go ahead and pause the video, try to put it in a slope-intercept form, and it's y is equal to negative 2x minus 1. And we're going to go ahead and put it in slope-intercept form because you notice this last one asks you to draw it. And they're easiest to graph in slope-intercept form. Now the equation of the normal. Okay, now for the equation of the normal, we need to come back to the point-slope form. Okay, so to find the normal, you don't just switch the slope here. That's a big no-no. Okay, for the normal, come on, it's going to be y plus 3 equals, the normal is perpendicular, so instead of negative 2, it becomes positive 1/2. And that's it. then you could go ahead and simplify this. Again, if it's my test, that's good enough, but if you have to graph it, it's going to be easier to go ahead and simplify that in the point slope. And then in point slope form, that becomes y is equal to 1/2 x minus 3.5. Okay, then go ahead and draw them in the same viewing window. So what you need to be able to do is graph them together. So there's our original. There's our tangent line. So it touches right there. Okay, doesn't go through it. It just touches it. Now here is our normal line. Boom, perpendicular. Doesn't look perpendicular, but if I do a square, boom. Nope, still didn't, huh? Trust me, it's perpendicular. Square window. Ah, there we go. Anyway, they are perpendicular to each other. And there you go. That's how you find a normal line. This example has to do with speed, so connecting rates of change to how fast an object is moving at a specific, not time interval, but a specific moment in time. And that is instantaneous rate of change. So that is a specific moment in time. Okay, very specific. So it's at exactly 2 seconds, or as exactly 2.0435787 seconds. All right, it's not on a given time interval. It's not average. Okay, not average. So in order to find the average rate of change, you use algebra. In order to find the instantaneous rate of change, you use calculus. So let's try this. After t seconds, you've done this a lot of times in algebra. So something's falling, and its given height is 3t squared feet. How fast is the rocket climbing after 10 seconds? Well, if we find the slope on this graph at 10 seconds, it's going to give us how fast it's falling. Okay, so first of all, let's find the average, just for kicks and giggles. Go ahead and pause the video and figure out what the average rate of change for this is. Okay, so pause the video, find the average rate of change on your own. From 0 to 10 seconds. So average rate of change from 0 to 10 seconds on your own. Go. Okay, so after 10 seconds, the average rate of change is 30 feet per second. Okay, it's climbing pretty fast. Now what we're going to do is we're going to find the calculus part of it, so that's the instantaneous rate of change. Alright, so on the second one, to find the instantaneous rate of change, that's when you're going to use the limit as h approaches 0 of f of x plus h minus f of x all over h. Okay, so go ahead and try this one on your own, then come back to the video, see how you did. So pause it, try it on your own, come back to the video, see how you did. Come on. Okay. Now let's just walk through it together. I'm going to go kind of fast because I know you already did this on your own. It's just the limit as h approaches 0. Now you're going to plug x plus h, and I'm going to keep it as x. It doesn't matter. Okay, but I know x is 10. Okay, so I'm going to put 10 in there. And our function is 3t squared. Okay, so I'm going to plug x plus h in there. It's going to be 3 times the quantity of x plus h. Oops, x I know is 10. Quantity squared. Minus, then I'm just going to plug x in there. So f of x, just plug x in there. It's just going to be 3 times 10 quantity squared. All over, I know this is going to be h. Okay. Now when we simplify this, the 10 plus h quantity squared, you would have the limit as h approaches 0. Whoops, too far, come on. There we go. 3 times the quantity of 100 plus 20h plus h squared. All that minus 300 all over h. So again, the limit as h approaches 0, simplifying all this, if you distribute that in, you'd have 300, so 300, 60h, 3h squared, and you notice the 300 and the negative 300 cancel. So when you take 3 times 100, that's 300, that'll cancel with that, so those are gone. So all you'd have left is 60h plus 3h squared and that's it, all over h. So your constant should cancel there, all over h. Everything has an h, so take that out, the limit, because you can't plug 0 in. The whole idea, remember the limit, to find the limit of a function, the idea is to plug 0 in for h, but you can't because you'd have 0 on the bottom. But now, since everything has an h, it would just be 60 plus 3h over 1. Now I can go ahead and plug h in there, and so your answer would just be 60. Okay, so this thing is moving at 60, feet per second at 10 seconds. So that's the speed of this rocket at exactly 10 seconds. Okay, then one final example, horizontal tangents. Now, horizontal tangent is exactly what it sounds like. Okay, it's the horizontal, where the tangent, it's a tangent that is horizontal. And what's the slope of a horizontal line? Anybody? Anybody? 0. Good job. Slope of a horizontal line. Okay, so that's where the slope is equal to 0. So basically what you're going to figure out is you don't have a point. That's the problem. You don't know the x value at where this is horizontal. Okay, we could try graphing it. We can look at the graph. Let's go ahead and do that. Now looking at the graph, you can kind of tell where this is going to be horizontal. At this point, looks like -2. I don't know if it's exactly -2. It might be. I'm not really sure. Okay? Let's try to find it. So the first thing we need to do is find the general equation for the slope. So what that means is we don't have an x value. So it's just going to be the limit as h approaches 0. Come on. There we go. The limit as h approaches 0. And f of x plus h, so I'm going to put x plus h in there for x. This is going to be 3 minus 4 x plus h minus x plus h, quantity squared, minus f of the x, so I'm just going to keep everything as x. Now normally on ones we've done before, okay, we've put an actual value in here for x, but we don't know what that value is. We don't know where it's horizontal. Okay, we're guessing it's at -2, but we don't know for sure. Alright, so now we want to know where all of this here is equal to 0, because all of this stuff on the left side of this equation represents the slope of that line. And we want to know where the slope of that line is equal to 0. Here's the hard part. Simplify all this. So this is a nightmare. If you want to, go ahead and try this on your own. To make this video a little shorter, I'm just going to go ahead and let you try this on your own, then we'll come back and then we'll go over it. So if we just run through this really quick, check your work. We set it up. Then from there, you went through, you had to simplify all this. Calculus, remember, I probably said this a lot of times in class. I know I said in my notes, calculus is just algebra on steroids, man. Algebra on steroids. A few new ideas, a lot of tough concepts, but it's algebra on steroids. So if you don't get algebra, this is going to be hard for you. Okay, you're trying to pump up 400 pounds on your back when your legs can only handle 100. Okay, you're going to buckle under the weight, so get on the train, man. So anyway, when you simplify this out, this is what you get, and you notice a bunch of stuff cancel, and a lot of stuff should. Okay, most of our x's, all of our constants cancel. That should always happen. So then we're left with just negative 4h minus 2xh minus x squared over h is equal to 0. Again, we can't plug 0 in for h yet because you have it on the bottom. Now down here, all your terms have an h in common, so we get rid of one. And now you notice we can go ahead and plug h in, and you just have negative 4 minus 2x equals 0. Solve for x, you get x equals negative 2. But in this problem, they specifically asked at what point. Okay, so we go ahead and give them the coordinate. Just be safe. Give them the coordinate. Okay, if they had asked where does this occur, then x equals negative 2 is an okay answer. But the question was at what point, so we give them the coordinate. All right. Anyway, that's it for this section. This is probably the hardest section in all of chapter 2. At least I hope it is, because I thought it was difficult for me when I saw it the first time, second time, third time, fourth time, fifth time, sixth time. Coming around my 7th time, got a little easier. Okay. Anyway, watch the video again if you need to.